Morning, guys. Today we're going to solve a ventrimeter with a manometer problem. So here's the problem. A seawater flows through a vertical ventrimeter if the deflection of glycerin E is equal to 5 centimeters. Determine the pressure difference between the inlet and the throat if the throat is 25 centimeters above the inlet. So from the figure, we can see here's the E, which is 5 centimeters. And let us put H as the height difference between the inlet and the throat. So what I did here is just, I've put down all the givens here. From the inlet to the throat, the distance is 0.25 meters. And E, which is the difference between glycerin, is 5 centimeters or 0.05 meters. And we know that the unit weight of glycerin is equal to 12.4 kilonewton per cubic meter rather. And the unit weight of salt water is 10.03 kilonewton per cubic meter. And what I did here in the left side of the paper is just I wrote a pressure equation from point 1 to point 2. So what I did here is just P1 plus the pressure in this side of the manometer, Y is the height, and the 10.03 is the unit weight of salt water, because pressure is equal to unit weight times height. And we have a minus sign here because our pressure is going up. So E times 12.4, which is the unit weight of glycerin, and E is the height. And we have again a minus sign for our pressure here, which is 0.25, this one, H, minus E minus Y here. And all of this will be multiplied by 10.03. As you can see here in the figure, it's 10.03 because it's the unit weight of salt water. And all of this is equal to the pressure 2 from point 2. So what I did here is just I've distributed this function here so that you can get this. And then as you can see, I have cancelled out here because they have opposite signs. And so then this equation will be reduced to this equation here, right here. After that, you can see that you can identify now your pressure difference. So your pressure difference is 2.626 kilopascal. For the question of determining the velocity at the throat, if the velocity is 6 times that of the inlet, and the question determine the discharge if inlet diameter is 450 mm and coefficient of discharge is equal to 0.98, will be discussed by Renz Kabunok.
So, good morning guys. We are here to continue the problem and to answer letter B, which is to determine the velocity at the throat if the velocity is 6 times that of the inlet. So, from the Bernoulli's equation, which is P1 over specific gravity plus V1 squared over 2G is equal to P2 over specific gravity plus 6V1 squared over 2G plus 0.25. So we have the P1 minus P2 from our letter A, and we have the specific weight of the liquid. Then we subtract it by 0.25. We transpose the 0.25 here to the left, then we equal it to 6V1 squared minus V1 squared over 2G. So we transfer the V1 squared here to the right in order to subtract the same terms. So 0.2618 minus 0.25 is equal to 5v1 squared over 2g. Now we are tasked to find the velocity at the throat, so we equate the equation by having the v1 isolated, then which is equal to the square root of 0.0118 times 2 times 9.81 divided by 5. So solving this equation, we get velocity 1 is equal to 0.0963 meters per second and velocity 2, which is 0.578 meters per second. And then the last problem, which is to determine a discharge if inlet diameter is 450 millimeters and C is equal to 0.98. So the equation for getting the discharge is equal to area times velocity times coefficient. So the area, which is pi over 4 times 0.45 meters squared, is multiplied to by 0.0963 meters per second, which is our velocity 1, and the coefficient, which is 0.98. So by solving this, we get the discharge, which is 0.015 meters cubed per second. And that's it for today, and thank you for listening. God bless and have a nice day.